Hello everyone. In this video, we're going to be solving a quartic equation. We have x to the fourth power plus 6x cubed equals 128, and we're going to be solving for x values. Now, this is a quartic equation, and there's a quartic formula, but I don't think you want to use it. If you look it up, I think you'll find it on Wikipedia. It's ginormous. It's huge, crazy. But there's definitely ways to deal with quartic equations. We're going to talk about them first, and then I will show you a method that I learned from Nadia Fan, for which I'm very grateful, and we'll finish with that. Okay? So when you get a polynomial equation, one of the things you can use is rational root theorem. So you can go ahead and put everything on the same side, and if there are any rational solutions to this equation, they have to be factors of 128. Why? Because Vieta's formulas, okay? Especially when the leading coefficient is 1, so you have a monic polynomial, you can basically just look at the factors of the constant term. Since 128 is 2 to the 7th power, the only factors of 128 would be powers of 2, including 1, which is 2 to the power 0. So there are quite a few options. If you think about it, it's 2 to the 0 to 2 to the 7. That's going to make 8 factors and double that number because of negatives, and you'll have 16 candidates. Well, would one of them work? You can go ahead and test it out. I don't want to spoil the surprise because I'm going to show you an alternative method, actually probably 2 more alternatives. And then when we find out the solutions using another method, we're going to find out if there are any rational solutions as well. Okay? So at this point, I don't really want to disclose any of that information, but something to check for. Okay? It's laborious. Yes, it's kind of time consuming. Probably you don't want to do it. But it can be done sometimes. When you have a smaller constant term, of course, with many, imagine you have a prime number, there would only be so many factors. So that's one way to approach it. Let's consider that first method. Real quick, I just want to give you an idea. Not all methods have to work, by the way. I just give you a method, and a method may not work because this is more realistic. Like if you're solving a problem, you try something, it doesn't work, and then you try another thing. So the second method that I'd like to show you is getting rid of the x cube. In other words, getting a depressed quartic. I know it's not necessary. You don't have to do it that way. And I'm going to show you an alternative to that as well. But here's how it works, at least. You can replace x with y minus 2. And that 2 comes from, actually, that's not right, not y minus 2. I was just dividing by 3, sorry about that. I'm supposed to divide 6 by 4, so that would be 3/2. And the reason behind that is you take the second coefficient, you divide it by the degree of the polynomial, which is the highest power, and then you negate that term, and then use your other variable. So in other words, like y plus minus, okay, I should probably write it like this. Y plus the opposite of 6 divided by 4. Makes sense? That's how it works. Now, what is going to happen if you substitute this into our equation in 2 places? You're going to get rid of the cubic term, which is y cubed. And then you're going to end up with something like y to the 4th plus blah, blah, blah. And you're going to have a y squared. You're not going to have y cubed. You're going to have a y in a constant term, okay? But at the end, this comes down to the following. You can kind of write it as y squared plus ay plus b multiplied by y squared minus ay plus c. And b times c is going to give you the constant term. But why did I use plus minus ay? Because that indicates there's no cubic term. Make sense? Because the only way to get the cubics is from a quadratic and a linear term, which is y squared multiplied by a coefficient of or multiple of y. Make sense? So this will give you a system of equations which is solvable, but that's going to result in a cubic equation. So that way you reduce the degree from the 4th power to the third power, and cubic equations can be solved similarly. You get rid of the terms, so on and so forth. But if there are any rational terms, or you can turn it into polynomial with integer coefficients, which means you have rational roots, right? Then it will be easy to guess and check. Okay? So I'm also going to leave that up to you because this is a lot of work and I'm kind of lazy. And I just want to leave that as an exercise. The first and the second methods. Okay? First method is rational root theorem. Second method is get rid of the cubic term and factor it and turn this into a cubic equation, in other words. Okay? Here's the third method, for third and foremost, not like first and foremost, but it's a really, really cool method to use. Okay? And this was something that I didn't know earlier, but thanks to comments from Nadia Fan, I'm very grateful I learned something new. So here's how the idea works. We're going to add something to both sides so that the left-hand side becomes a perfect square. And of course, we want both sides to be a perfect square, but the first step is making the left-hand side a perfect square, because after that, we can turn the right-hand side into a perfect square as well. I'm going to show you all the steps. Okay? So here's how it works. This is x squared squared. This is 2 times 3x times x squared. What does that mean? It means that you have the a squared plus 2ab plus b squared. Yes, remember the formula? This is how you can complete the square here. So now, and that's equal to a plus b quantity squared. So this is my a, and this is my b. So it needs to be followed by b squared, which is 9x squared. That makes sense? And of course, I need to add it on both sides, of course. No question about it. But when I did that, I basically got the following. I got x to the fourth plus 6x cubed plus 9x squared, which is x squared plus 3x quantity squared. Beautiful. And then this equals a quadratic, which is not a perfect square, but that's okay. We'll fix that next, okay? So to be able to fix that, now here's what I'm going to do. I'm going to add to both sides a hocus pocus, amazing term, by the way. I'll be adding 2k times x squared plus 3x plus k squared. You know why? Because this just becomes another square. Think about it. If this is like m squared plus 2k m plus k squared, it's m plus k quantity squared. Make sense? Awesome. Now this is going to equal what? This is going to equal 9x squared plus 128 plus 2k x squared plus 3x plus k squared. Of course, I have to add that term on both sides, right? Cool. Now what happens on the left-hand side? We get x squared plus 3x plus k quantity squared. This is still a perfect square. You see, we had a perfect square. We added something to both sides, and it's still a perfect square. And now we want to make the right-hand side a perfect square. And that can be done 9 plus 2k. That'll be the coefficient of x squared from here and from here. And then we have plus 6kx plus 128 plus k squared. Guess what? That is the end of it. Now, we want the right-hand side to be a perfect square as well, and it's quadratic, so its discriminant needs to be 0. If you tried it here, this would not be a perfect square, so you had to add something, a linear term and a constant, which is not going to really change a lot. Well, at a quadratic too anyways, but it's still quadratic. That's the good thing. So we're going to look at the delta, b squared minus 4ac. Awesome. And that's equal to 0. Beautiful. Now we can kind of put things on either side. This is 36k squared, and this is equal to 4 times 9 plus 2k times 128 plus k squared. From here, we're going to try to find the k value. But first, let's simplify this a little bit. 4 goes into 36 9 times, and this kind of gives us a nicer equation. Let's go ahead and distribute both sides. We get 9k squared equals 9 times 128. I would look at it this way. 10 times that is 120/80. Just subtract this from the number. You're going to get 2, 5, and 11. So that's 1152 plus 9k squared plus 256k plus 2k cubed. 9k squared cancels out and we end up with an amazing equation. 2k cubed plus 256k plus 1152 equals 0. Guess what? We can divide both sides by 2 to even simplify this further. K cubed plus 128k plus, what's half of this? 550 plus 26, that is 576. And that's equal to 0. So here's the fun part. You're going to look for the k value, right? So first of all, notice that k cannot be positive because this would give us not 0, right? It will be positive. So k needs to be negative, right? And we can kind of guess and check our work. Try a couple different numbers. K equals -1 is not going to work. -2, probably not going to work. Maybe -3 would work. Let's give it a try. This would give us -27. If you multiply this by 3, you should be getting 360 plus 24, which is -384 plus 576. Too small. Maybe k equals -4 will do the work. So you basically try different numbers until you find the right answer. That's going to give you the k value, and then you can kind of proceed with the solution from there. So let's go ahead and find the right value. So we did not try k equals -4. Let's go ahead and plug it in. -4 cubed is going to be -64. -4 times this is just going to be -512 plus 576. And yes, Houston, we have a solution. So k equals -4 works. And now we can go ahead and plug it back in. K equals -4 is going to work. And what does that mean? It just means that we have x squared plus 3x minus 4 squared equals, now on the right hand side, you're also going to have a perfect square, right? When you plug in -4, you're going to get x squared minus 24x, and then plus 128 plus 16, that will be 144. And guess what? That's going to equal, that'll be x minus 12 quantity squared. And then from here, you're going to get two solutions. Let me show you how we can solve this. We can basically first set these two equal to each other. That's going to give us a quadratic equation. From here, we get x squared plus 2x plus 8 equals 0. This one doesn't have any real solutions, but you can still solve them. This will give us x equals -b plus minus the square root of b squared, which is 4, minus 4ac, which is 32. That's -28. That'll be 2 root 7i divided by 2. In other words, that's going to be -1 plus minus root 7i. Those are complex solutions. And the other solution is going to come from the negation of the right-hand side. And if you put it all together, you're going to get x squared plus 4x minus 16 equals 0. Let's solve it a little differently. Add 16 to both sides, then add 4 to both sides. That'll give you x squared plus 4x plus 4 equals 20. But this is x plus 2 quantities squared, which is equal to 20. If you square root both sides, you'll get plus minus 2 root 5. And this will give you x equals -2 plus minus 2 root 5 as the real solutions. So we have two complex, two real solutions. Let's go ahead and take a look at the graph of these two. Yay, they intersect at 2 points, which brings us to the end of this video. Well, thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.